This is just the explanation for those that may not be able to understand it. I am going to be writing down the statement down. If you're not strong in mathematics, this kind of question will be a bit confused to you. But I assure you, if you pay maximum interest on this particular explanation I'm going to give, you will understand it to the fullest. Now, we are asked to show that 35 is an irrational number. Pay attention. Pay attention. Now, how do we know a rational number and what irrational number? Now, a rational number are expressed in the ratio of two integers. Ratio means over, which means a rational number can be expressed in the ratio of a over what b, whereas irrational number is the what is the opposite. That is, it cannot be expressed in the ratio of what two integers. I am using this one point of rational and irrational number. We know that rational number they are terminating or they have repeating blocks, while irrational numbers they are not terminating and they don't have repeating blocks. But I am concentrating on the ratio of two integers to solve this particular question or to prove this particular question on the board. Now, how do you solve for this? Now, there is this question requires logical reasoning and using some proof to show that root 5 is an irrational number. And for you to show that this is a rational number, we are going to be making use of what we call proof of contradiction. Now, what is a proof of contradiction? Proof of contradiction is a statement which is used to assume the opposite of a statement which was made. Now, what is the opposite of irrational number? Using proof of contradiction. So we assume that the opposite of this statement is what? True. Now, when we solve and at the end, we found out that what the opposite of this statement is not true. Therefore, this statement is what? Correct. Now, how do you solve? By proof of contradiction, we will what? We will take root 5 to be what? Rational. And when it is rational, it is expressed in the form of a over what? B, which is what? Ratio of two what? Integers. Now, I've started solving. I've started showing the proof. Now, we have to eliminate the square root by squaring both sides. And then you have here to be what? 5. This square will cancel the square root. And you have here to be what? A squared over b what? Squared. Whereas this b squared will multiply this and we have here to be what? 5b squared equal to what? A squared. Now, let's not forget that a over b must not be what? 0. B must not be what? Be 0. Which means b is a non-zero what? Number. And in rational number, we assume that a and b are not common factors. Understand them. A and b are not common factors. If we arrive at the end that a and b are common factors or are multiples of each other, it means that this statement is what? Correct. That root 5 is an irrational number. Let's continue. Now we have here to be 5b squared equal to what? A squared. Now, on the left side, you have that 5b squared. We have that we have 5b squared, which means that if here is 5b squared, a squared must be a multiple of what? 5. That is the condition that holds for proof of contradiction. If the left hand side is a multiple of what? 5, the right hand side must also be a multiple of what? 5. Now, we take a to be equals to what? 5k, where k is an what? Integer. Where k is an what? Integer. Now, as k is an integer, we are going to be substituting 5k in what? A squared. And then you have here that what? 5b squared is equal to 5k all squared. And then you have here that 5b squared is equal to 25k squared. 25k what? Squared. And then this is 5. And here we cancel. and then you have here cancelled, and b squared is equal to 25 divided by 5 will give me what? 5k what squared. Now you see that if we continue doing this, we'll be having the multiples on both sides. Now the other time we have here 5b squared is equal to what? A squared. And then you have here that b squared is equal to what? 5k squared. Now on the right side we have 5k squared. Therefore b, the left hand side must be the multiple of the what? Right hand side. You see that when you continue doing this now, it will continue being a multiple of each what? Order, or each other, which means that what? A and B are common multiples or common what? Factor. So if A and B are what? Are common what? Multiples. Don't forget that from the proof of what? Contradiction, irrational numbers are not common what? Factors, or are not common what? Or multiples. But if at the end of this what? Statement, we see that they are both what? Common what? Multiples or common factors, now we will take the proof that root 5 is what? An irrational number. Is an irrational what? Number. Now I'm going to be writing down the solution. This is just the explanation for those that may not be able to understand it. I am going to be writing down the statement down so that you can put it down and then look at it and be watching the explanation. Thank you for watching. Bye bye.